Okay, I'd just like to talk through the solution to this problem, and I've tried doing it different ways. It's effectively a question asking for the dry density of a soil, and it gives some information about it. So in one sense it's a pretty academic sort of question, but we're asked to find the dry density. And in the past I've kind of done what I normally do with these problems, and I'll just show you what I've done previously, is almost done it mathematically, where I go through all the equations and work through and follow it all through, and I get to the end of this all, and this is a solution, and it will get there, and it's a question of just putting in the numbers to find out the dry density. But when I looked at that whole sheet of calculations, I thought that just looks horrible. But hopefully it's useful, but it still looks horrible, so there's got to be a better way of doing it. So this is my attempt at a better way of doing it. And I think it's just down to, we are much better, I think, at visualizing stuff. Maths and abstract things are always quite complicated, but let's just try and see what this soil looks like, and then we'll work out what to do, because ultimately dry density, give it some more dry density, is obviously a density, so therefore it's mass divided by volume. Mass divided by volume. And then we ask ourselves what mass and what volume. Well, it's basically the mass of the dry solids divided by the total volume. So let's just go straight into seeing what this looks like, because I think that will make our whole life a lot easier. We've got effectively a sample of soil. I'll just draw it quite big. Okay, of which, this is the model, if you like. This is solids, and this is voids. Okay, and in those voids is water. So that's what we've got. And we could just, I guess we could put a bit of colour on this to make it all a bit. So there's our solids, and then we've got a whole lot of voids into which are, if we separate out the voids from the solids, that's what we've got, and then there'll be some water in there. And so let's just try and work out really what we're dealing with. So that's the kind of model. And what we say is we have a unit volume of solids. So i.e. that solids is 1 cubic meter. The density of the solids, okay, is described by how much denser is it than water, and that's where this GS comes in. Okay, because the mass of this, so this is volume, let's say mass on here, the mass of the solids, okay, is down to how much heavier it is than water. And if we had 1 cubic meter of solids, of water, that would weigh 1,000 kilograms or 1 megagram. So, and the GS says how much denser is it. So effectively that's GS times by the mass of water, of the equivalent weight of water. So we've basically got 2.7 times 1.0 megagram per meter cubed. So that solids weighs 2.7 megagrams, yeah, or I'm not a great lover of megagrams, so that's 2,700 kilograms. So that's what the solids weigh. So we know what the solids weigh, and we know what volume it occupies. Let's now look at the water. So water is found by the moisture content, and moisture content, W, or sometimes given the symbol M or W, is basically a ratio of the mass of water divided by the mass of the solids. So, and we know the mass of the solids is 2.7. So our mass of water is equal to the water content, 9.9, multiplied by 2,700. That's a percentage, so we have to divide it by 100, and we would get our mass of water. Okay, so I'm just going to put that in my little calculator. 9.9 times 2,700 divided by 100, and we have 267.3 kilograms of water. Okay, we're dealing with real numbers here, so it makes it a lot easier. So that's the amount of water we've got. In terms of the volume it occupies, well, we know what the density of water is. This would also have a volume of, let's go to the next stage, I suppose. That would have a volume of 267.3. Well, this will be converting that to volume, would be 0.that cubic meters. Okay, 276 liters. So that's the volume of water. 0.26. Looks like a thing there, isn't it? And 0.26 cubic meters. So in the voids we've got water up to 0.26 cubic meters. Sorry, there's a thing there, should there? So we're making progress. Now we just need to get an idea of just about the air. Okay, I'll perhaps pop it down here so you know how much air we've got in here. So we read that from the question where it says about the air voids ratio. And air voids ratio is equal to the volume of air divided by the total volume. Okay, now we don't know what our total volume is in one way, but we know that, but we don't know that. Okay, so let's think a little bit more about our total volume. Our total volume, well, we know it's made up of volume of mass of the solids. So the volume of the solids plus the volume of water plus the volume of air. So we know the volume of solids because we've got that. That's 1 cubic meter. Our volume of the water is 0.267, and then we've got a volume of air. And bizarrely, our volume of air, okay, is actually, we found from that equation here, is the air voids multiplied by the total volume. So we've got an equation where we've got total volume on both sides, so we just have to rearrange that equation to work out what is your total volume of air. Okay, or your total volume. There's a bit of maths involved with rearranging that equation. So our total volume is equal to, and there's a little bit of maths involved in here, but you end up with 1 plus the volume of water divided by 1 minus the air voids ratio. So I've jumped a step there, which you probably might not like, but if you do the maths of rearranging this equation, you end up with the total volume. So we've ended up, basically with the model, where we've worked out what is the volume of air, the volume of water, the mass of water. We've got all the pieces of information, okay, in terms of, that would be in, cubic meters. And once you've got all that information, then you can really just start feeding things back into, the original equation. In this case, it's for dry density, but it could be anything you could be asked about. Okay, and then maybe you're asked, next, what's the void ratio, E values, whatever you're asked to. Once you've got the actual raw figures, if you like, the actual quantities of water and solids and air, then your life becomes, a lot easier. So I hope that's useful.